Okay, let's assume here we have got a seesaw that is pivoted at the center of mass. On page 41, here, okay, on page 41 here, can you read the top line of page 41?
Explain how it's possible for a seesaw to be an equilibrium in the position shown in figure 5.7.
Yeah. So if I were to displace it a little bit like this, can you see? Do you think it will just stay there? And the answer is yes, it will just stay there. Because, can you see this line of force? This line of force does not go away from the pivot, therefore there is no turning effect for this weight, okay? But if, for example, if I pivot at the top here, it's a different story altogether, is it not? Because then now the center of mass is below the pivot, and when the center of mass is below the pivot, you turn this, then this line of force will have a perpendicular distance here, and therefore this will turn. If I pivot it here like that, it will turn horizontal, and when it turns horizontal, then again the line of force will pass through the pivot, therefore there is no distance. So this one will always go horizontal, but this one will not go horizontal when I turn it like that. It will not, okay? So there are a lot of things which are below the pivot. Let me show you this. You see, the center of mass of this whole thing is just below here in the air, which you can see. So when I put it here, it's below the pivot here, somewhere here. So if I displace it, the center of mass will move outright, then this will move back. So if I move this way, then the center of mass will move from here to here. Then you'll move back. So if I move this, give me your finger. Give me your finger, yeah. And this is very stable. Very, very stable. Now let's try this. Let's try this. I have two forks. Where is the center of mass of this coin? At the center, right? At the center of the coin. Where is the center of mass of this fork? Is somewhere here. Okay? So if I put these two forks together, where is the center of mass of these two forks? Here and here, here and here. Then the center of mass of these two forks will be somewhere here in the air. Here, somewhere here in the air. And hence, if I put this like that, if I put it this way, what do you think will happen? This one will balance like this. And this is very, very stable, because the two forks will have a center of mass here, the coin has the center of mass here, and then they combine to have the center of mass below the pivot here. Give me your finger. And it's very stable. You see? It's very, very stable. Whether it's like that or like this. And of course this one can pivot here.